We present a quick guide to tools developed in the COGNITWIN project by the University of UOULU Intelligent Machines and Systems Research Unit. A number of general-purpose tools developed in the COGNITWIN project are openly available. Tools have been developed for solving the project pilot problems. We are using the MATLAB environment. 7 tools are presented on system identification, physical modeling, model tuning, and state estimation. Models derived based on first principles can be complex, and it can be difficult to find feasible tuning parameters. The PMFIR approach can be used, for example, to improve model dynamics, or to tune physical model to site conditions and data. We avoid the need to tune components inside the model, by using external dynamic filters, in series. Filters can also be added in parallel. The tool considers model structure selection, parameter estimation and predictions. Papers provide more information on the approach and its applications. To use the tool, download and open the zip file. The README file contains a brief description. The main code is in the PIMFR class file. A demo M file is provided. For additional features, see the help documentation. In the demo, a random sample data rows are generated, for system inputs, for dummy physical model outputs and measured outputs. The object is then constructed, and the parameters of FIR filters estimated. The class includes a plot method for simple plotting. The demonstration can be run by typing the name of the M file in the MATLAB command window. The plot provides an illustration of the outcomes. The left top shows the bode plot for the output filter. The right plots show step responses for the output and input filters. The unscented Kalman filter is used for state estimation. It fuses the information obtained from both model and data. UKF belongs to nonlinear Bayesian state estimation methods. It approximates the propagation of estimate distribution in time. UKF provides reduced computational load by the use of unscented transformation. The implementation enables a selection of a subset of states to be considered. A conference paper provides more information on the approach, with an application. To use the tool, download and open the zip file. The main interface is in the UKF filter function. A demonstration script illustrates the use. In this implementation, both prediction and measurement update are done in one function call. Running the demonstration simulates the estimation of two states. With the approximate uncertainties drawn, the impact of noise levels and missing data is demonstrated. Bayesian state estimation provides a quantification of state uncertainties, based on state and measurement noise properties. The ensemble Kalman filter is another nonlinear Bayesian state estimation method. The approach uses a randomly perturbed ensemble for approximating the distribution by mean and covariances. The implementation follows the MATLAB nonlinear state estimation syntax. As a class with methods for prediction and correction, the main file is the ensemble Kalman filter class definition. The demonstration illustrates the repeated use of prediction and correction steps. Updating the state estimate object, myKF, in time, using the model. And correcting the estimate with measurement information. The demonstration script shows how to solve a simple state estimation problem. Again, a two-state system is considered. If the conditions are favorable, the ensemble Kalman filtering can provide feasible results, with a smaller number of model evaluations. It may then be a feasible choice for larger state dimensions and heavier to compute process models. Model-based approaches, for monitoring and control, require a dynamic model of the process. A heat exchanger model was constructed, starting from first principles. The model zip file contains a script for initialization of heat exchanger model parameters. Demo file is included to demonstrate heat exchanger model in action. User can choose different parameter values, for example different heat exchanger dimensions, in the initialization script. Heat exchanger model works in Simulink environment. After user have set desired parameters in the initialization script, run the script to save required parameters to workspace for Simulink model. User can play with Simulink model. In this demo run, we monitor pipe temperatures of heat exchanger, but user can also choose different variables to be monitored in scopes. The outlier detection tool is used for validation of measurement data. Quality of data is required for data-driven model applications. Ellipsoidal peeling method is used to detect outlier candidates from batch of data. The main file is the validation batch class definition. Various data validation actions are implemented as methods. A demonstration script illustrates how to use the tool. First, the object is constructed. Selected methods are then applied to the object, including outlier detection and plotting. Subspace identification finds linear time invariant system approximations from input-output data. MOESP is a subspace identification method. This tool can be applied to MIMO data. Tool is implemented as a function. A demonstration script illustrates how to use the tool. First, input-output data is read. Then identification is done applied. Plots visualize how the approximation fits with original data. The Prony method is another subspace approach. Our implementation considers second-order, linear time invariant, single input single output models. The tool is implemented in the .prinem file. Again, a demonstration script is provided to illustrate the use of the tool. Data is loaded, and the tool estimates a linear time invariant state space model from the data. In this demonstration, demo script was run and results were plotted. As an end result is a figure, where LTI model's output is plotted versus original output signal, when the same input signal is fed into both systems. We have presented some general-purpose tools, outputs of the COGNITWIN project. The link to downloading tool zip files can be found from the COGNITWIN Toolbox portal. Thank you for watching.